Welcome to part 2 of the video on implicit differentiation. In the second video, we're going to solve 2 additional examples with implicit differentiation. As a second example, let's consider this equation here with variables x and y, and we're asked to find y prime, that is the derivative of y with respect to x. So first we apply the derivative to both sides. We take the derivative on the left side and the right side. On the left side we can distribute the derivative like this. And here in the first term we have 4x squared times y. And remember that we're considering y as a function of x. So here we have the product of 2 functions of x. And to calculate this derivative, we must apply the product rule. Here we have dy dx, that's y prime. And in this derivative in the right side, we have the derivative of x cubed, that's 3x squared. So we replace these two things. And now let's apply the product rule to this term. Applying the product rule, we have that this derivative will be the derivative of the first term, that is 4 times 2x times the second factor plus the first factor times the derivative of the second factor, that's y prime. Then here we have 5y prime, and on the right side we have 3x squared. So we have this equation here. That becomes this. Now we see that we have an equation with y prime. So we only need to solve for y prime, and then that will end the problem. So we take the common factor y prime here. We get this, and then we subtract 4xy from both sides. And then we divide by this to get y prime. And this is the answer. Here the detail is that in the expression for y prime we have y here, and generally that doesn't matter. There are some cases in which you can replace y for its expression as a function of x, but that's generally not necessary, and you can leave the answer like this. Let's solve another example. Let's consider this equation. Here a is a constant, and let's try to find y prime. We take the derivative of both sides. On the right side we have a constant, so its derivative is 0. On the left side we can distribute the derivative like this, and here we use the power rule, that is, well, in the second term we will need to use the chain rule, but in the first term we apply the power rule to get 2 over 3 times x to the 2/3 minus 1, and now we need to apply the chain rule because y is a function of x. So we get 2/3 times y to the 2/3 minus 1. That's the derivative of the outer function. Now we must multiply by the derivative of the inner function. The inner function is y, so its derivative is y prime. So we have this equation here, and what we need to do now again is to solve for y prime. If we do that, well, that's okay. We divide everything. We eliminate the constant there because on the right side we have 0, and then we solve for y prime. Here we subtract this term to both sides, and then divide by this factor, and we get this expression. Again, we see that in the expression for y prime we get y, and that's normal, that's okay. So you see that in these cases, in these two examples that we've seen, implicit differentiation is useful because the equations are pretty complicated. You may be able to solve for y, but it is not worth it. It is much easier to use implicit differentiation to find the derivative of y. So that's all for now. Thank you for watching and see you next time.